Mr. Abbott, and here we are back again to the sun's path for Bellmore Lab. We were on step number 10, using the protractor to determine and record the altitude of the noontime sun for each season. Now, obviously, you could look at the model here, and the noon sun is here, and you have the protractor where each line is going up by 1 degree. The slightly longer line in the middle is going to be 5. So this is 20, 30, 25 in the middle. Looking at this, you're going up 25, 26. So to me, it's around 26. This one, you've got 50 degrees. So this appears to be between 50 and 49. Up here, we've got 70. 71, 72, 73, so this appears to be between my line for 73 and 74. So if I had to eyeball this, they would probably give you plus or minus 2 degrees for your answer if this was a free response on the Regents exam, but I'd say probably 49. Okay, this would be like 26 and a half. And I would get 72.5 degrees for this. The better way to do this, honestly, is by calculating the altitude of the noon sun, and you can do that based on your understanding of the seasons. Now, down here on the bottom, it's always easy to start off with the noon sun for the equinox. So, if we find the noon sun for the equinox, what you're going to do is you're going to take 90 degrees, which is the position at the zenith. So if I do 90 minus my latitude, that's going to give me the noon sun on the equinox. Okay, so for this example, it tells us our latitude is 40.5 degrees, so I do 90 degrees minus 40.5 degrees. Okay, I could even take out a calculator if I'm not good at math, and I might suggest that would be a good thing for you to do. So if I do 90 minus 40.5, when I do that, I get 49.5 degrees. And that's what I sort of said. It was between 49 and 50, so the altitude is 49.5 degrees. Now, once you've figured out the equinox angle, what happens is you get plus or minus 23.5 degrees for each season. Okay, every season, the vertical ray of the sun shifts between the Tropic of Capricorn, the Tropic of Cancer, okay, and the equator. So each season, the sun is going to appear to move either 23.5 degrees higher or 23.5 degrees lower. If they give you one seasonal path, you can figure out the other ones by knowing whether the sun gets higher or knowing the sun gets lower. So if I wanted to do the summer solstice, which is 621, I would take that 49.5 degrees, I would add 23.5, which I think you know is the tilt of the Earth's axis. So I have 49.5, I add 23.5, and I get an answer of exactly 73 degrees. So the highest angle the sun ever gets for us in Bellmore is 73 degrees. I'm going to clear my calculator. In winter, instead of having a higher, longer path, in the winter we get a shorter, lower path. So for the winter solstice, or 1221, I'm going to do 49.5 degrees, which is the equinox angle. This time I subtract the 23.5, So I do 49.5. I divide by, not divide, sorry. 49.5 minus 23.5. Okay, and then I would get 26 degrees. All right, so I would label this as a 26-degree angle. So the angles that you had, okay, were 26, 49.5, and 73 degrees. Now, if you look at that from 73 to 26, if I do 73 minus 26, that means the total change from the summer solstice to the winter solstice, this angle of the sun, that's the change in the altitude for a full year. The sun goes up or down 47 degrees between the seasons, which is why there is such a large difference in the amount of energy we get, whether it's summer or winter. Now, we have completed step number 10. The last thing that you have to do on the diagram is highlight. It says highlight the equinox path in yellow. So for the equinox path, the equinox, it always rises due east. In the morning, the altitude increases. You hit solar noon, and it would be setting due west. That path is exactly 12 hours. So that would be 180 degrees to go from east to west, and you would have a 12-hour length of daylight. So the yellow, the equinox path is the yellow. Summer solstice, they said use green, so I'm going to take my green highlighter. For the summer solstice path, I'm going to highlight it in green. Sunrise would be north of east, the farthest north of east for the year. All morning long in the AM, it would be going up. You hit solar noon, and then in the PM, it would be going down. So your summer solstice path on June 21st, you get the longest day of the year in terms of daylight hours. Okay, so that's what your summer solstice path looks like. Now, for the winter solstice, it says highlight the winter solstice in blue. So the winter solstice path, I'm going to highlight in blue highlighter. It's the only blue highlighter I could find, but it rises north of east. Okay, from sunrise to noon, the altitude increases, and then from noon to sunset, the altitude is decreasing. So the sun is on the horizon. You get the longest shadows around sunrise and sunset. Now, all we have to do is consider the questions. So our model is done. We've drawn that. Now we can flip to the back. Is the sun ever directly overhead in New York? Okay, obviously, if you look at your diagram, the highest angle we got was 73. So the noon sun never is overhead in Bellmore. Now, make sure you explain it. Okay, you could say a lot of things for that. One explanation is the maximum value is 73 degrees. Okay, for the sun to be directly overhead, you need to be between the Tropic of Capricorn and the Tropic of Cancer. So one explanation would be that Bellmore is higher than 23.5 degrees north latitude. And if you are above the Tropic of Cancer in the northern hemisphere or below the Tropic of Capricorn, you can never have the sun directly overhead. Now for this one, you may as well write it in a complete sentence. What is the highest altitude? The highest altitude would be the summer solstice. So you might say in Bellmore, the highest altitude is 73 degrees on 6/21, which is the summer solstice. Now, if you didn't put in all the details on yours, don't change it. Just make sure you understand what you're doing. What date and season has the longest amount of daylight hours? The length of the path tells you the number of daylight hours. So if we go back to this, you'll notice the equinox path is in the middle, the summer path has the longest highest value, and the winter path has the shortest lowest one. So clearly the summer solstice path would give you the longest daylight hours, and we've all experienced that. Okay, so what date and season? So the summer solstice, which is June 21st, has the longest amount of daylight hours. Now, the real term for that is duration of insolation. But the question says number of daylight hours, so you could leave it as number of daylight hours. Now, the longer path shows a longer period of daylight. Now, it also has the highest angle, but the angle isn't telling you how many hours there are. The angle is just telling you how high in the sky it is. If you are near the equator, okay, it really is going to be, you know, a high angle, but it doesn't necessarily mean it's a long day. Now, I'm going to try to adjust this a little bit to see if I can zoom in. It's not really letting me zoom in, so maybe we'll have to modify this for another video. Which date and season has the shortest duration, shortest number of daylight hours? How can you tell? So winter, which is 12/21, has the fewest or the shortest, the fewest hours of daylight. That's the first part. How can you tell? The path for 12/21 is the shortest. The equinox path would be 12 hours. 12 times 15 is 180 degrees. For the summer solstice, it's 15 hours. So if you looked at the length of the path for the summer solstice, if you looked at the summer solstice, you do 15 times 15. So the summer solstice might give you 225 degrees. For the winter, 9 times 15 would give you only 135 degrees. So the path for 12/21 is the shortest. That means it's 135 degrees between sunrise and sunset. It's going to give you the fewest hours. Okay, what is the latitude for Bellmore? Okay, Bellmore is at 40.5 degrees. Now, the most direct way of measuring that is by looking at Polaris. So, the altitude of Polaris equals 40.5 degrees. Another way of explaining it, you could have talked about the noon sun. Okay, so a comparable answer is the noon sun on the equinox is 49.5 degrees. So because the sun is 40.5 degrees down from the zenith, that's telling you you're at 40.5 degrees latitude. All right, what date will sunrise be exactly due east and due west? Okay, so the two dates are on the equinoxes, which are 3/21 and 9/23. The sun will rise due east and set due west. Okay, so basically for the spring and fall, on spring and fall, the seasons are going to rise due east. The sun is going to rise due east and set due west. So spring, the vernal equinox is 3/21, and the autumnal equinox is 9/23. During which season does the sun rise north of east? In summer, the sunrise is farthest north of east. Okay. During which season does the sun rise south of east? Well, if I look at the diagram, east is here, south of east would be on this side, and the only part where the sun rises south of east would be the winter solstice. So in winter, the sun rises south of east. Okay, for half the year, from the vernal equinox to the winter solstice, and then back from the autumnal equinox to the winter solstice, the sun is moving farther south each day. Then from the winter solstice to the vernal equinox, from winter to spring, the sun appears to be moving north towards east each day, but it's definitely south of east in the winter. If the sun rises north of east, where will it set? Sunset will be north of west. Now, this is going to be essentially in the summer. You're going to get a longer, higher path. So when they're saying sunrise is north of east is here. When the sun rises north of east, it goes to the highest altitude, and it's going to set north of west. If the sun rises south of east, where will it set? Sunset will be south of west. So that essentially is this model. Honestly, we're going to be using this model a lot this year. You have to know it. I hope you find this helpful. Please remember that you will be getting a lab quiz on this where you'll be getting Regents questions based on the content of this, the apparent path of the sun. You get the longest, highest path for the summer solstice. The equinox path always rises due east and sets due west. The shortest, lowest path is the winter solstice, which is 12/21. Okay. Each season, the angle of the sun either shifts up or shifts down by 23.5 degrees. Now, I would like to thank Tom Gazda again for giving me the inspiration for doing it. This lab has been brought to you by the Earth Science Reference Tables. There is no way to succeed at this course without knowing and understanding the reference tables incredibly well. So never forget your reference tables and make sure you know how to read the charts. Thank you very much. This is Mr. Abbott, and I approve of this homework or this lab assignment.